An example on projectiles. Let's start off just by reading through the question. A ball is projected with speed 40 meters per second from a point P on a cliff above horizontal ground. The point O on the ground is vertically below P and OP is 36 meters. The ball is projected at an angle theta to the horizontal. The point Q is the highest point of the path of the ball and is 12 meters above the level of P. The ball moves freely under gravity and it hits the ground at the point R, as shown in the diagram above. Find, first of all, the value of theta, and secondly, the distance OR. Well, we're either going to consider the horizontal aspect of the motion or the vertical aspect of the motion. And the question is, for which part of the motion do we have enough information? Well, a little bit of thought will show that if we consider the trajectory of the ball up to the highest point, we should have enough information to find out what theta is. So we're going to consider just the vertical motion in part A, and hopefully we'll be able to find out the value of theta. I'm going to mark on my diagram the following information. I like to resolve the initial velocity directly, so the horizontal component would be 40 cos theta and the vertical component would be 40 sin theta, and I also like to mark on which directions I will take as positive, and I'll keep those directions as positive consistently throughout the problem. So for part A, we're going to consider the vertical motion up to the highest point. So let's list down what we know to begin with. U is 40 sin theta, the acceleration will be minus g, given my frame of reference. The velocity at the highest point, the vertical velocity, will be 0, because of course the particle momentarily stops rising, and the displacement to the highest point is 12. The correct formula to choose here would be v squared equals u squared plus 2as. You should always state that in your solution. We can now substitute the values in directly, and our objective is to find out theta. So let's make sine squared theta the subject of the formula to begin with. We can now take the square root of each side to lead us to sine theta equals plus or minus the root of 24g over 1600. It's only the positive root that we're going to require here, and so if I pop all that into my calculator and do the inverse sine as required, I find out that theta is 22.5 degrees. You should also check this on your calculator to ensure that you agree with the results that I've got. Now I'm going to leave the actual full answer for the angle theta on my calculator so that for my subsequent results I will get the most accurate answer that's possible. Now the next job is to find the distance OR. Now for the horizontal aspect of the motion we're essentially just going to be using s equals ut plus a half at squared, but of course the acceleration is 0 in the horizontal sense, so I'm just going to be using s equals ut. Now s is what I need to find, that's the distance OR. U I know, it's 40 cos theta, which I now realise is 40 cos 22.5, but I don't know what the time is. So we're going to consider the vertical motion again, and we're going to find out how long it will take for our projectile to be at a displacement of minus 36 meters below where it started. So we're going to consider the vertical motion. Let's write down what we know so far. So we know that u is 40 sine 22.5, we know that the acceleration is minus g, we know that we're interested in the displacement when it will be minus 36, and we simply want to know how long that will take. S equals ut plus a half at squared is the required formula, so I'll state that. Substitute in the values, so it'll be minus 36 equals parenthesis 40 sine theta times t minus 4.9 t squared, which I can rearrange to make into a quadratic equation as shown below. Now I could have put 40 sine 22.5 in here, but it just looked, I thought, a little bit neater to leave it like this, and the value of theta I still have on my calculator. So I've used my calculator to find out the solution to this quadratic. One of the values of t was negative, that's not the one that I want, and the one in fact that I did want came out to be 4.695 seconds. Well, we're almost there. We now just need to consider how far the ball will move in a horizontal sense in 4.695 seconds. So I'll say I'm going to work with the horizontal motion. and I will list down what I know so far. So U is 40 cos 22.5, T is 4.695, and S is what we're after. S equals UT is the required formula. Let's put all our variables in so that it looks like this. Reach for the calculator and we get 173 metres when rounded to 3 significant figures. My layout this time is a little bit cramped up. That's simply because I wanted to fit all of my working onto one page. But nonetheless, the actual structure that I've used is what you should try and emulate when you answer the questions yourself.